Hello everybody and welcome back to MrMiers Math Channel. Today we're going to talk about circles and ellipses, which is section 13.3 and 13.4. Our goal is to write and graph equations of circles and also to graph ellipses. Alright, so let's get started. Alright, first, a circle is the set of all points in a plane that are equidistant from a given point called the center of the circle, where the radius is the distance from the center to a point on the circle. All radii of a circle are congruent, and circles with the same radius are congruent. Right? A segment that contains the center that also contains 2 points on the circle is called the diameter. We're going to be using some of these features to graph and write equations for graphs for our circles. All right, so let's say let's let x comma y, just some point, represent any point on a circle with the center at the origin and radius r. By the Pythagorean theorem, x squared plus y squared equals r squared, right? And that's how we could form the equation of a circle where the radius is r and the circle is centered about the origin. So using x squared plus y squared equals r squared, we can find the radius. So in this example, r squared is 9. So if r squared is 9, that means r is going to be positive 3. Positive 3 because when we're talking about distance, that's going to be a positive measurement. We're not going to have a negative distance. And then we already said that these circles of this form are centered about the origin. Now to draw this circle, we could draw the center. And then we could go 3 units in each direction, to the right, to the left, up, and down. And then we're gonna do our best to form a circle here. All right, usually I like to start pretty wide at each one of these points. And that just gives me some good guidelines as to how I'm gonna draw this circle. So obviously I'm not the best artist. Wow, this is terrible. All right, but that's good enough to give us a picture of what the circle might look like. All right, let's move on to the next example. The standard equation of a circle is x minus h squared plus the quantity y minus k squared equals r squared, where the center is the point h comma k. We've seen this type of thing when talking about parabolas in the last chapter. Still, the radius is r, so our equation equals r squared, so we could just take the square root to get the radius. So in example 2, part A, the center of the circle is going to be the point 0, comma, negative 9. Right? Notice in terms of x, we're not subtracting anything in this quantity, so that makes 0. And then in terms of y, we're subtracting negative 9. Right? We've got to change that sign. And then the radius is going to be the square root of 10. Sorry, the square root of 100, which is 10. For part B, the center of the circle is going to be negative 7, comma, 5. And then the radius in this case will be 7. All right, so pretty simple to find the center and the radius of a circle given the equation in standard form. Now we're going to write the standard form of the equation given the center and its radius. So just remember that in standard form, we have the quantity x minus h squared plus the quantity y minus k squared equals r squared, where the center is h comma k. So this is h, this is k, this is r, and now we can just fill it in to get our equation in standard form. So we have x minus negative 4, so I'm just going to write plus 4. Minus and negative is the same thing as adding. All right, and then we have y minus k, so that's the quantity y minus 13 squared equals r squared. Since r is 5, we can square that. If we square 5, we get 25. So this equation reads the quantity x plus 4 squared plus y minus 13 squared equals 25. All right, now in the next example, we have a center of 0, comma 0. So this is centered about the origin. So in this case, we can refer to the previous equation, which was x squared plus y squared equals r squared, to write this equation. So we have x squared plus y squared equals 3 squared, and 3 squared is 9. All right. Now let's go on to graphing. All right, so in example 4, it says identify the center and radius of the circle and then graph the circle. All right, so the center of this circle is the point 2, 2. 2 is what we're subtracting from x, 2 is what we're subtracting from y. Okay, remember 9 is r squared, not r, so that means we have to take the square root and we get a radius of 3. So this circle is centered about 2, 2, and then we're going to go 3 units in each direction, right, left, up, down, and then form our circle. Doing the best job that we can. All right. Same thing in the next one. We're going to identify the center, which is a -2, 3, and then the radius would be 2. So we're going to graph the center, -2, 3, and then go 2 units in each direction. Good stuff. Now we're going on to the next section, which talks about ellipses. Now ellipses are very similar to circles. We'll see some key features that are very similar between circles and ellipses. Believe it or not, we use ellipses all the time. Circles are a type of ellipse, really. We could, the standard form of a circle would satisfy the equation for an ellipse. And we have many ellipses that we could see from day to day, like orbiting planets, the moon's orbit, stadiums like the San Diego Chargers Stadium, and even some funky airplanes like you see on the top right. All right, so for an ellipse, we've got many different parts of an ellipse, and we're only going to focus on a few of these parts, enough of the parts to be able to graph the actual ellipse. Okay, so we have 2 axes. One is a major axis. This is the bigger one. And then we have a minor axis. Now the intersection of these 2 axes forms the center of the circle. All right, we also have foci, 2 foci in an ellipse, which actually is what creates the ellipse shape. There's a relationship within the foci that creates that shape that forms the ellipse. But one of the main things is that the foci lie on the major axis. So we have 2 axes, a major and a minor, and the intersection would be the center of the ellipse. The minor axis joins the 2 co-vertices, is what we might call them, whereas the major axis joins two of the vertices. Right, and we're going to use these 4 points as well as the center to draw our ellipse. So let's take a look at the equation now. Notice a good amount of this equation is very similar from an ellipse to a circle. Obviously, one difference is we see that it equals 1 and not r squared. Okay, that's the difference between the circle and ellipse. And then also we have a and b in the denominator of both of these terms in this equation. All right, the center is still h comma k, and a is what's going to tell us how many units we travel to the left and to the right. All right, just think about it like this: a is under x, and when we're talking about the x-axis, that's left and right. B is under y, and when we're talking about the y-axis, that's up and down. So b is going to tell us how many units we travel up and down from the center. Now, in the equation for an ellipse, obviously this says a squared, so we would have to take the square root to get a. Same thing for b. All right, so let's get into our first example here. We have an equation for an ellipse, so we're going to identify the features. One of those features is the center. That would be 2, 1. And then we've got to identify what is a equal and what is b equal. Right? 4 is a squared, so that means a is 2. 16 is b squared, which means b is 4. So we're going to graph the center, 2, 1, and then a is telling us how many units to go to the left and to the right. So we're going to go 2 units left, 2 units right, and then b is telling us how many units to go up and down. So that's 4 units up, 4 units down, and now we can draw our ellipse. Okay. Now in the next example, we have a different equation. Once again, so it's still the same process. Let's find the center, which would be -3, -2. Now remember, this is a squared and this is b squared. So if a squared equals 2, that means a equals the square root of 2, right? Which is approximately about 1.4, we can think of it. And then b squared is 25, so b is 5. So we're going to graph the center, -3, -2. In terms of a, that's left and right, so we're going to go about 1.4 units to the left and to the right. And then in terms of b, that's up and down, so we're going to go 5 units up, 5 units down. And now we're going to graph our ellipse. Oof. We should still have rounded features at each one of these vertices and co-vertices. It shouldn't look like a corner. Obviously, it's a little tough to do on this tablet. All right, moving on. All right, for example 8, this one's a little bit simpler. Notice we don't see anything subtracting from x and from y, so that means the center of this ellipse is the point 0, 0, or the origin. And then a squared and b squared are both perfect squares, so that means a and b are going to be really nice. Take the square root of 9, we get 3. The square root of 4 is 2. So a is 3 and b is 2. So we have the center of our ellipse. We're going to go 3 units to the right, 3 units to the left, 2 units up, 2 units down, and then draw our ellipse. Oof. That's a little rough. Hopefully you do a little bit better job than I do in terms of drawing these graphs. I'm not very good at that. All right. Now, last one. Example 9. We're still doing the same thing. I know it's a lot of repetition, but obviously practice makes perfect. So we're going to find the center, A and B. That center lies at -1, -2. Now notice, in terms of y, there's nothing in the denominator, right? It doesn't appear that there's anything in the denominator. There's always going to be an implied denominator, and that implied denominator is 1, right? So that means b squared is 1. If we take the square root, that means b is 1. A squared is 25, so that means a is 5. So the center is -1, -2. We're going to go 5 units to the right, 5 units to the left, 1 unit up, 1 unit down. All right. Once again, I'll do my best here. Ooh. All right. So we have just the basics on circles and the basics on ellipses, enough to be able to draw a rough sketch of both of those things. All right, if you found this helpful or enjoyed the content, like, subscribe, and share. Thank you, and have a good day.